Hey, welcome to the quiz review. So, I have created a few questions that basically mirror what you're going to see on the quiz and will help us review the main topics and also the question types that you're going to see when you go and take your quiz on Monday. So, here we have a spaghetti factory, and this spaghetti factory bought a whole ton of noodles. In fact, it bought 300 pounds of them. It used 6.5 pounds per day. How much did it use after 3 days? Well, that would be 6.5 pounds times 3 days. We need to use number sentences to show our work and figure out the answer. So my first approach would be to figure out how much it spent over the course of 3 days, and then after that I would figure out how much it had left. So what I would do first is probably multiply 6.5 times 3. So the way that I would do that is just a normal multiplication sentence. I would certainly count 6.5 times 3 written long ways as a multiplication sentence. 3.5 is 15, so we put our 1 at the top. 3 times 6 is 18 plus 1 is 19. And we don't want to forget our decimal, that's 19.5 pounds. Just to double check our work, 6.5 is close to 7. And 9.5 is close to 21, so that's about right. Here we go again. 19.5 is close to 21. So now we know how much pounds of spaghetti they used. We want to know how many pounds of spaghetti they have left. So then we just have to subtract 300 pounds minus 21.5 pounds. Well, that's the same thing as 300.0 pounds. And in fact, let's write this a little bit bigger so that we can see what's going on here. So I'm going to write 300.0 minus 21.5. Then it's a standard subtraction problem. I carry all the way from the left, 2. That becomes a 10 because I carried the 1. Then I borrow, so it becomes a 9. Standard subtraction, so I carried the 1 and it becomes a 9. And now I have a 10 on the right. So 10 minus 5 is 5. I have my decimal, then 9 minus 1 is 8. And then 9 minus 2 is 7. So I have 278.5 pounds of spaghetti left. And I could box that in as my answer. And we're all done with that problem. Let's check out the next one. Now, every problem here, as I said earlier, is very close to one that you would see on your quiz. So don't be too worried. Some of our more difficult concepts are not actually tested on. So, moving down, there's a guy named Ray. Ray has been in debt for a while now. He's in debt $28 right now, but he used to owe more. He's been paying back $5 a day for the past 5 months. We want to know two things. Basically, how much in debt was Ray when he started, and at the present rate, how much longer will it take him to pay off his debt? And we have to explain it. So when Ray started, well, let's figure out how much he has now and add on how much he had per day. This is not too difficult. There are a couple ways you could do it. We're going to zoom in a little bit. So he has $28, right? Well, he's in debt $28 right now. It's funny because you can kind of do the word problems without negative numbers. When he started, he was going to have plus $5 times $5 per day. So we have the amount that he's in debt right now, current debt, and then we have amount he paid back per day times the number of days. That would give us $28 plus 5 times 5 is $25. When I add the two, I get $53 that he was originally in debt when he started. There's another way that you could do it too. Now, notice that it's talking about debt. You could also do this using negative numbers. Well, instead of doing that, I think I'm going to show you how to check your work using negative numbers, since we already solved it one way. Now, you could say that he has negative $28. Well, we're going to check our work. He had negative $53. He was negative $53 in debt. And then he added on, he paid back $5 per day for the last 5 days. Let's change this to days. He's been paying back $5 per day for the last 5 days. I don't want to mislead you because that's per day and that's times the number of days. So he was $53 in debt, and then he paid back $5 per day times 5 days. Well, that's a negative plus a positive, which is equal to negative 53 plus 25 equals, well, I don't want to forget my negative sign, and I'll put my dollar sign in there too, equals negative 28. So if we represent debt as negative numbers and paying it back as positive numbers, we see that our signs really do work out right. When I solved the problem, even though we were talking about debt, the easy approach, I thought, was just to pretend that debt is a positive number. So that's his current debt. That's how much he had been paying back, and that was a total debt. So we want to know how much longer it's going to take him to pay off his debt, and we have to explain our reasoning. Well, we know that he's paying back $5 per day, and he's got $28 to pay off. Now, we could add on the number of 5s that it's going to take him. After day 1, he's paid off 5, and I'm going to write money paid off and days. So he pays off $5 on day 1, another $5 on day 2, another $5 on day 3, and by now he's paid off $15, another $5 on day 4, that's 20, another $5 on day 5, that's 25. Now he has 3 more, so he's just going to pay 3 back on the 6th day. So I could say that it takes him 6 days. You could also do this using a number sentence. One way we could do that would be to say that he owes $28 and he's basically paying it back in increments of 5. So if we divide by 5, we actually get 5 with a remainder of 3. Now that's a difficult answer to interpret because we have to think, what is the 3 for? Please excuse my handwriting. 5 remainder 3. Well, really what that means is that we have $28 divided by $5 per day equals $5. But honestly, I think this approach is a little easier. It says we've got to explain our reasoning. Well, we know we got it right because he paid back 5, and then he paid back 5 more, and then 5 more, then 5 more. On day 5, he's paid back $25. But don't forget that even if we just put this on the test, we haven't really answered part of the question, which is to explain the reasoning. So I'm going to put that I wrote how much he paid back each day. And then I added up the amounts. We knew that after 5 days, he paid back $25. So I would say that after day 5, he still had $3 left to pay off. So he has to do that on a different day, right? He doesn't have it all on day 5. It took him 6 days. That would be a really excellent explanation. Now, you could also do the division version, and you could say that the remainder he has to pay on day 6. That would be a reasonable explanation as well. But this is a pretty foolproof method. Let's go on now to some simpler problems. However, these are ones that use negative numbers in addition and subtraction, and even in multiplication, kind of unavoidably. The first one you're going to see is something similar to 7 minus 9. Now, I know a lot of you had been asking questions about what does it mean when you're adding and subtracting negative numbers, and how do you know what the answer is going to be? Well, to finish answering this question, I want to show you an analogy. Now, I know we talked about hot air balloons a little bit, but we can go back over that again, just to help us check our work. Now, I'll do the simple number line model that you're probably familiar with first, because that will give us some intuition. Here's 0, and then we have 1, 2, 3, 4, 5, 6, 7. If we subtract 9, that means we're going in the left 9 marks. If I go back 7, I know that I'm going to be at 0 again. After that, since I'm subtracting 9, I have to go back 2 more. By then, I'm at -2. Another thing that you can remember is that you find the difference and then take the sign of the bigger number. So another way I could solve it would be to rewrite this as 9 minus 7 equals 2, and then say that the 9 is the one that really had the negative sign. Since 9 was the one that originally had the negative sign, I know that since the problem is flipped, the sign will also be flipped, so that my answer is actually going to be -2. So if I reverse the order of a subtraction problem, the sign changes, it flips around. Another way to look at it is with the hot air balloon problem. Remember that in our hot air balloon analogy, we had little balloons on top of our hot air balloon that we kind of attached when we wanted to make it go up even farther, just like in the movie Up. In this one, I start out with 7 little hot air balloons. So I've done 5 so far. Here I go with 2 more, and they're lifting my hot air balloon up. So let's remember that each balloon is a positive number, and they make your balloon go upward by 1 unit of altitude. Whereas on the bottom, when we want to hold the hot air balloon down, we attach some sandbags. Each sandbag is a negative number. And, not only is it a negative number, but they make the balloon go down by 1. Most of us know that if it brings it down by 1 and you cut it off, it's going to go up again. Similarly, if you cut off a hot air balloon, if you cut off one of the helium balloons, that is, then our balloon will go back down. Let's use the sidebar as a number line. It's basically like a vertical number line that describes where our hot air balloon is. We can again start at a positive 7. Now we attach 7 air balloons, as exemplified by our number right here, and we went up to 7. So let's say that 7 is right up here. So we have 6, 5, 4, 3, 2, 1, 0. And then what this number sentence is saying is that we're subtracting something. Specifically, we're subtracting a positive number. Now we know that subtract means take away, so we're taking away, or cutting off, 9 balloons. So we have taking away 9 balloons. Means that we're going to go down again by 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That makes our hot air balloon go down by 9 units of altitude. Now it's in the crater, not up on the mountain. And this is where our hot air balloon is now, at -2. So that should remind you a little bit of the hot air balloon analogy. We're going to go ahead and solve some other similar problems that you might see. Another similar problem that you might see is, and we won't do the hot air balloon analogy again, but you can go back to it to study, is -7 plus, well, let's try a similar one, +9. Remember that any addition problem can be rewritten as a subtraction problem. Basically, you take the positive number and you put it first, and then whatever number was negative, that one goes second, and you just subtract it. This becomes 9 minus 7, which is a +2. Again, if you want to, we could go back with the with the hot air balloon analogy and use it to check our work. So if we start out with -7, that means we're starting out with 7 sandbags on our balloon instead of 7 helium balloons. So we're going to go down to a -7. -4, -5, -6, -7. So here's our hot air balloon now. Then it says we're adding on, addition symbol, 9, that's a positive number, 9 balloons. So we go up by 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, because each balloon makes our hot air balloon gain 1 unit of height. Now our hot air balloon is at a +2, and you are nice and up there in the sky. So that's how we can check our work for this problem. Let's try a slightly different problem. I know you've seen ones where you have negative numbers and a subtraction problem, and they kind of cancel each other out. That can be confusing. Let's try -12 minus 10. -12 minus 10 has a subtraction sign and a negative sign. When that happens, the subtraction and the negative cancel each other out, and we can use our hot air balloon analogy to see why. We have -12 plus 10 equals, this is where we have a negative number and a positive number again. Remember I said we could rewrite that as a subtraction problem? I'm just going to rewrite that as 10 minus 12, because I can and because it means the same thing. Well, 10 minus 12, if I were subtracting 10, I'd go back to 0, but I have to subtract 2 more. I know that's going to bring me all the way down to -2. But let's try the hot air balloon analogy again. This one's a little trickier, and I'm going to have to add a little bit more space to my number line. Now, I'm going to go all the way down this time to -12. So we have -8, -9, -10, -11, and -12. This is where my hot air balloon is starting out, because I attached 12 negative sign sandbags. So then I have to cut off, because it's a subtraction sign, 10. What am I cutting off? 10 is a negative number, so these are also sandbags. So I have 12 sandbags, and then I'm cutting off 10 sandbags. So what's going to happen when I cut off those sandbags? Well, my hot air balloon will go back up again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That brings me back to -2. This is the new position of my hot air balloon, just as I predicted when I did the math. Now, I usually just cancel it out. Like, here's the fast way that I would do it if it was just me knowing my negative numbers really well. I would see that problem written down, and I would just go do a slash mark. If they're next to each other, I just turn them into pluses, and then I say that one's bigger, so it's -2. That is the fast way that I would solve this problem. Let's try a similar one, but one that begins with a positive number. How about 11 minus -7? Well, in this one, I could do it the fast way and cancel it out and say that's the same thing as 11 plus 7. When I add them together, I get 18. Should be +18. I can check that again with my hot air balloon analogy. But I'm going to have to add on some more numbers because my number line doesn't go all the way up to 18, and I know it's going to have to. It's kind of helpful to be able to use the margin of your notebook paper for that. 8, 9, 10, 11, 12, 13, 14, 15, this is number 16, 17, 18. Alright, now we have a lot of traveling to do. We started out with 11 little helium balloons on top. That means our balloon started at 0, but because ordinarily it would start at 0, but we put on 11 balloons, so it drifted upward to an altitude of 11. Then we put on 7 more balloons. These are also balloons because this is a positive number. So when I add 7 more balloons, of course it has to go up by 7 more. 1, 2, 3, 4, 5, 6, 7. And what number are we at? 18. So we've successfully checked our work. You might see another similar problem. And so I would highly recommend being able to solve these. You're also going to find some multiplication and division on your quiz. Now, these are ones that you might have seen briefly in your homework, but in order to be super prepared for your quiz, I'm going to show you everything you need to know about multiplying and dividing with positive and negative numbers so that you can get it right. The last 4 problems are devoted solely to multiplying and dividing with negative numbers, even though we didn't talk about it that much yet. Let's turn the page because we're not going to be using that hot air balloon analogy again. Our first problem that you might see is something like 36 divided by 4, except each of them is negative. Here's the deal. When you have a negative number and you're dividing by a negative number, they both cancel out, just like when you're subtracting. So I could rewrite that problem as 36 divided by 4. Now, this is also, it kind of looks like a fraction. It is a fraction. Fractions and dividing are pretty much the same thing. Now, this is equal to 36 divided by 4, which comes out to 9. It's kind of as if we can come up with a picture for it. I had a pie, and I had cut it into 36 pieces. Here's 8. So, I guess that would give me 16. And it's not going to be a very neat pie. I'm just going to give us 36 slices. And I needed to give slices to 4 people. That's how much I owed them. So, I guess I can't give pie to negative 4 people. So that analogy doesn't make too much sense. When would you divide by a negative number? We'll have to come up with an example. We'll come back to that. The next problem that you would see is when you have to divide, but there's one negative number and one positive number. So this one is easier to come up with an example for. You might see something like 42, or negative 42 as it may be, divided by 3. Well, you could also write that as negative, kind of with the negative on the outside, 42 divided by 3. Now, 42 divided by 3 is just equal to, we might have to do some real division here. 3 goes into 4 once. 4 minus 3 is 1. We bring down the 2. 3 into 12 is 4. So that's just going to be equal to 14, but we still have to carry over our negative sign. If there's 1 on the side, it stays, and that's negative 14. The fact that you can pull out the negative sign from the problem actually works on the same problem above. Remember how we had negative 36 divided by negative 4. We could say that's also equal to negative over just negative 36 divided by 4. Like negative 1 over negative 1. And if you divide negative 1 by itself, any number you divide by itself, in fact, is just going to come out to 1. So that's 1 times 36 over 4, which is just 1 times 9, or 9. Not a problem. The next type of problem you would see is multiplying with negative numbers. Similarly with division, when you have one negative number in your multiplication problem, it carries over. This is the same thing as negative times, or negative 1. Negative is the same thing as negative 1. 25 times 5. Well, 25 times 5 is 125. So this is just negative 125. Not a problem. We carried our negative number over. Sometimes I think this part is actually easier than it is with the multiplying and dividing. Let's try a multiplication problem that actually has two negative numbers in it. How about negative 11 times negative 7? Well, similarly, we can pull out the negatives. This is basically the same thing as negative 1 times 11 times negative 1 times 7, right? Because if you did negative 1 times 11, you'd get negative 11. And if you did negative 1 times 7, you'd get negative 7. Now, when you do that, that's the same thing as negative 1 times negative 1 times 11 times 7. You can group them together. That's called the associative property, by the way. The one where I move things around as commutative and then I group them as associative. Negative 1 times negative 1, that comes out to 1. That's why they cancel out. It's like I had a negative and then I got rid of it again and it came out to positive. Times, well, 11 times 7 is 77, so that's just going to be an answer of 77. Now, if I were going to just solve this problem quickly, see where I have the two negatives? I do the same thing that I did with subtraction. Every time I do that, I kind of mark it reflexively now because I'm so used to solving problems that have a lot of negative numbers. Then I would just rewrite it as 11 times 7 and solve it and get 77. That is basically it for your quiz. So, in review, you should be able to solve basic word problems. And those word problems, you don't necessarily need to be able to solve them using negative numbers, but you should be able to explain your answers. You may see one with loans, but even then, you can rewrite it with positive numbers. That should make it a lot easier. Then you'll have to be able to solve basic problems with adding and subtracting negative numbers. You're not going to see anything bigger than 20. It's all in the... And lastly, after you are able to add and subtract with negative numbers, you'll see just a couple of problems on multiplying and dividing with negative numbers. And negative numbers are a big focus of the quiz, and they are a subset of the word integers. So whenever we're talking about integers in class or your book says integers, really what it means is that whatever you can do with positive numbers and negative numbers. And that's it. Good luck on your quiz.